going to do collisions in 2D motion. We know we have inelastic collisions. When the collisions happens, they actually join the masses and then they go, and only momentum is conserved. So P in equals P out. And now we also know about elastic collisions. Momentum is conserved. Also, kinetic energy is conserved. So elastic collision, there's going to be some bounce in there. The cars can have different velocities. And then sometimes in a collision, you can have a mixture of those two. We know that EK in, the kinetic energy, it is going to be the kinetic energy out. So that's what we know. And we only did that in one dimensions. So one dimension was, just going left or right. What happens if I have two dimensions? Well, in two dimensions, we have to think about directions. We have to think about the X and Y components. Because if I have momentum is a vector, it can have some sort of angle. So if I know the resultant momentum, I would have to find momentum in the Y direction. So you can split momentum into components. But if I was dealing with elastic energy and kinetic energy, you cannot split. You cannot split energy into X and Y because energy is not a vector. So therefore, it does not have an X and Y component. Energy is still conserved, but you will not have the X and Y component. So that's a problem. And we're trying to solve for the final speed of the puck. Obviously, what is the speed of this puck if it's at rest? What is VB equal to? Yeah, if this is at rest, this is at 0 meters per second. So therefore, do I know the momentum of A? Yes, because we know that momentum is equal to mass times velocity. Step 2 is I would set up your equation table. Determine the momentum now in the X direction of A because momentum in the X direction, 0.1 kilograms times its velocity, and it's going in the X direction. It's clearly in the X direction, 5 meters per second. How about the momentum in the Y direction? Do I have any momentum, Terry, in the Y direction? Oh, no. So we're just going to put 0. Puck B in the X direction is at rest, so the velocities are both 0, so it's 0 and 0. The momentum I only have here is 0.5 kilograms per meters per second in the X direction, and I have 0 kilograms per meters per second, 0 momentum in the Y direction. For object A, I know this angle, so you can determine in the X direction because that's the X component of the momentum. And then in the Y component, we put the mass 0.1 degrees. Sine 30, we're going to get the Y component. We're going to get PY and then PX. 0.1. And it's going to be the velocity of B, and it's going to be, again, cosine theta, because we don't know this angle right here. And in the Y direction, it's going to be the same, 0.1 the kilograms times VB sine theta. Agree? Must be 0.5. Agree? Because the P in must be equal to the P out. So if I had an initial momentum of 0.5 in the x direction, I must have that same there. And what must the total in the y direction be? I had an initial of 0, so I'm going to have a final of 0. Agree? In the x direction, we have 0.1 VB cosine theta plus this one right here. Because this is the x component, it must be the add up. So you're going to plus 0.17 kilogram per meters per second. We can change that to, instead of VB cosine, this right here becomes my speed in my x direction. So it's going to be 0.1 times Vx. So we found the velocity in the x direction by taking the component of cosine and whatever that angle is. We're going to use the same idea now in the y direction. In the y direction, VB sine theta is equal to the VBY. So therefore, VBY will be equal to what? It will be equal to negative 0.1 kilogram per meter per second divided by 0.1. What do I get? What is the final speed in my y direction? It's going to be equal to negative 1 meters per second. So therefore, the conclusion is my puck is right here, puck B. We know now the speed in the x, we know VBX. And we know the speed in the y direction, VBY. The speed in the x direction is equal to 3.3 meters per second. Agree? This was equal to negative 1 meters per second. So therefore, to find out VB, or my final speed, it's using the Pythagoras Theorem. VB will be equal to 3.3 plus 1 squared square root. What do I get? What is my final speed of object B, of my puck? Per second. But the thing is, we also need to find out the angle. So divided by 3.3. What is the angle that I get? Degrees. So when you're solving for two-dimensional problems, use a table, equation table. Think of the x and y direction. Okay? Then you can use an equation because we know that the sum of this momentum must equal to this. The sum of this must equal to that. So therefore, 0.5 kilograms per meter per second must be equal to the individual components of the momentum of for example, AX plus BX. So it would be equal to, for example, 0.7 plus 0.1 VB cosine theta. And after that, we're trying to find out what this is. VB cosine theta is the x direction component. After you find your x component and your y component, you can find out the VB component, and then you can use these two to use Pythagoras theorem to find out the resultant velocity plus the angle. So right here, the final conclusion is the speed of my puck. Therefore, the puck is going at 3.3 meters per second at an angle down of negative 17 degrees. And that's how to solve for two-dimensional word problems.